Good evening to all. Myself Thota.Akhilasri. Today my seminar topic is stationary process. Now let's go over stationary process of random variables step by step. What is random process? A random process or stochastic process is a collection of random variables indexed by time or space. X of t belongs to capital T. Here x of t represents random variables at a time t and capital T represents a time index. It can be discrete or continuous. So x of t represents how a random quantity changes over time. And now we can discuss first order stationary process. Random process overview. A random process x of t is a collection of random variables indexed by time t. We study its statistical properties, that means mean, variance, correlation, etc. And this mean, variance, correlation are the properties of the random process or stationary process. What does order means in stationarity is first order depends only on the first moment. The first moment is mean and second order depends on the first and second moments. That means mean and autocorrelation. Highest order involves Highest order involves higher moments or joint distributions. Definition of first order stationary process. A process x of t is called first order stationary if its mean first moment does not change with time. Expectation of x of t equals to mu equals to constant for all t. That's it. It only cares about the mean being time invariant. Mathematically, for any time shift tau, expectation of x of t equals to expectation of x of t plus tau. If in case it is true, the first order stationary, and if it false, if expectation of x of t depends on t, not first order stationary. And we can discuss the second order stationary process. What is second order stationary process? A random process x of t is second order stationary, also known as wide sense stationary. It can be denoted as capital WSS. Later we have to detailed explanation of wide sense stationary. If both, it means mean and autocorrelation are independent of time. It focuses only on the first two moments. Mean first moment, autocorrelation second moment. Mathematical definition. A process x of t is second order stationary if mean is constant, expectation of x of t equals to mu equals to constant for all t. Autocorrelation depends only on time difference and it can also called as lag. Rx of t1 comma t2 equals to Rx of t1 minus t2 equals to Rx of tau, where tau equals to t2 minus t1. Autocorrelation function ACF. For a WSS process, that means wide sense stationary process, Rx of tau equals to expectation of x of t into x of t plus tau. It measures how the value of the process at a time t relates to the value at a time t plus tau. Autocovariance function. The autocovariance the autocovariance is Cx of tau equals to expectation of x of t minus mu into x of t plus tau minus mu. And for WSS, that means wide sense stationary. It also depends only on tau. Now we can discuss the properties of Rx of tau. For a second order stationary process, Rx of 0 equals to expectation of x square of t equals to average power, that means maximum value. Number 2, Rx of tau equals to Rx of minus tau. It is an even function. Number 3, modulus of Rx of tau greater than or equals less than or equals to Rx of 0. And number 4, if Rx of tau equals to 0 for all tau does not equals to 0, the process is white noise. And the final summary is a second order stationary process has expectation of x of t equals to constant, Rx of t1 comma t2 equals to Rx of t1 minus t2. We can explain the different types of stationary process. We have the main two types of stationary process. They are number 1 strict sense stationary process, number 2 wide sense stationary process. Now we have to detailed explanation of strict sense stationary process. The strict sense stationary process, it can be denoted as capital SSS. A process x of t is strict sense stationary if the joint distributions like x of t1 comma x of t2 comma and so on x of tn is the same as that of x of t1 plus tau comma x of t2 plus tau and so on x of tn plus tau for any shift tau. Mathematically, f of x of t1 comma x of t2 comma and so on x of tn into x1 comma x2 comma and so on xn equals to f of x of t1 plus tau x of t2 plus tau x of tn plus tau into x1 comma x2 comma and so on xn. That means the full probability behavior is time invariant. Now we can discuss the wide sense stationary process. It can be denoted as capital WSS or weakly stationary. In practice, it's to check strict sense stationarity. So we often use wide sense stationarity which only looks at first and second order statistics. A process x of t is wide sense stationary if mean is constant, expectation of x of t equals to constant equals to mu. Autocorrelation depends only on time difference tau. That means Rx of t1 comma t2 equals to Rx of t1 minus t2 equals to Rx of tau. Now autocorrelation function for a wide sense stationary process, Rx of tau equals to expectation of x of t into x of t plus tau. It measures how the process values at different times are related. Now the conclusion of stationary process. In summary, stationary process are random process whose statistical properties do not change with time. This means the process looks the same at all time instants in terms of its probability behavior. Now we can discuss the key points of stationary process. Number 1, stationary ensures that the behavior of a random process is stable over time, making analysis and prediction easier. Number 2, types of stationarity. Already we have to discuss the types of stationarity like first order stationarity and second order stationarity and strict sense stationarity and wide sense stationarity. Now we can final conclusion of these all stationarities. Number 1, first order stationarity, mean is constant with time. Number 2, second order stationarity, mean is constant and autocorrelation depends only on time difference, that means lag. Number 3, strict sense stationarity, all statistical properties like all moments or distributions are time invariant. Practical importance. Most real world signals like speech, noise or sensor data, these are all the parameters of signals and systems, are approximately wide sense stationary, and this assumption simplifies many analysis in signal processing, communications, and control systems. Final conclusion: a stationary process is one whose essential characteristics, that means mean variance and autocorrelation, do not change with time. The stability allows for consistent modeling and analysis of random signals and is a foundation concept in random process theory and signal analysis. Thank you.